Okay, so the last thing I want to do with this tower is start to mess a little bit with how this twisting is happening. Right now, all of the angles are defined in this range, which will take this maximum twisting and separate it out evenly among the different floors. So what I want to do is start to mess a little bit with that so I can actually change the taper and adapt it the way I want. And I'm going to do that in two different ways. So one is with a graph mapper node in Grasshopper, which will allow me to change those values graphically within Grasshopper. And another way is by referencing a curve from Rhino and using that curve to actually drive the twisting amount of the tower. So the first thing I'm going to do is pull up a graph mapper node in Grasshopper. So I'll just type in graph mapper. And the graph mapper is an interesting tool. By default, there's nothing here in this box. But what it allows you to do is it allows you to specify one of several graphs to change your data. So basically how this works is there's an input range here and there's an output range here. And right now this straight line basically maps from 0 to 0 and 1 to 1. So it'll just reproduce your data exactly. So just to show you how that works, I'm gonna insert it here. So here I have my list of twisting values basically. It goes from 0 to about 4 radians. So I plug them in here. You can see that on my input I have going from 0 to 1 and then the same numbers here. And the reason they get cut off at 1 is because I'm specifying that my range is going from only 0 to 1. So the first thing I'm going to do is I'm going to double click on this and I'm going to change those ranges to match the range of my data. So you have to set this manually, and now I'm saying my data is going from 0 to 4. I want to map that onto 0 to 4. So now if I create a panel to see what that looks like, here's my original data. And I'm just going to copy and paste that panel so I can take a look at the data coming from the graph mapper. Okay, so you can see that with a straight line, there's a 1-to-1 relationship of the data. But what this allows me to do is by using any of these graph types, I usually use this Bezier graph. It's similar to like a curve component in Photoshop. It allows me to start to change those values to match a graph. So if you do this kind of curve, what this basically means is mapping from the input to the output. The output is going to increase more gradually and then decrease gradually. So it's going to kind of have a fall off instead of just going linear from 0 to my maximum rotation. It's going to have this kind of gradual fall off. And now if we plug in this graph mapper into the range, you can see that I've started to change how this twisting is occurring. So the maximum range is still the same, but now I'm squeezing the rotation more into the center. I can start to play with these different values to affect how that twisting is happening and get a more nuanced kind of control of my twist. Okay, so that's one way in which I can affect the twist of my tower. So I'll just delete these panels. I'll keep this graph in here. And this is interesting because it allows you to kind of have this visual image of what the twisting is doing right in Grasshopper. Another way that's very common to control Grasshopper is with geometry in Rhino. So far I haven't actually made any geometry in Rhino. You can see if I select all, there's no objects in the selection. If I hide this, there's nothing in Rhino. So all of my geometry is kind of living virtually within this Grasshopper definition. But a really powerful use of Grasshopper obviously is to instance geometry from Rhino and be able to dynamically affect geometry in Grasshopper through what you do in Rhino. So the first thing I'm going to do is create a simple 3-point spline in Rhino, and this will give me a basic curve that I can change, and this will actually drive the twisting of my geometry. Okay, so to reference it, I'm going to create a geometry node in Grasshopper, and then I'm going to right click on it. I'm going to go to set one geometry. This will bring up object to reference in Rhino, and I can just click on the curve. And you can see now the curve turns red because I've instanced it, and now it's living within the Grasshopper. And you can see here it says reference planar curve. Okay, so now what I want to do is I want to divide that curve into the same number as the number of my floors. So I'll do that through the divide curve node. The divide curve node will take a curve and a number of points. And here the default is 10, but we actually want to change that to match what we did with the number of floors in the tower. So I'm just going to visualize quickly our floors here. Okay, so now what it's giving us is basically 13 points. So we take the curve and we divide it by 12, and it's giving us all the points created through that division. And what I want to do now is basically take a value from each of these points and link it to the amount of curve happening in our model. So here we have these points. You can see they each have x and a y value, and the z value is 0 because it's lying on the xy plane. So to extract any of the parameters from a point, we can use the deconstruct node. So here's the deconstruct point. You can also find all these things in the top toolbar. So that particular node you'll find under vector point deconstruct, and this will take in a list of points and give you the x, y, and z parameters of each of those points. So in this case, I want to basically tie the x value of the point. So you can see x is in the red axis. I want to take this value and tie it to the amount of twist at each level. So it'll give us more control over the curvature, but it'll still be continuous because it's in a curve. Okay, so I want to basically take these x values and tie them into the rotation. So here it looks like our values range anywhere from 0 to about 8. Our values range to about 3. So this will be a little bit too much twist at first, but we can easily control that just by dividing the value out. So another shortcut for any math operations, if we want to decrease the range of this number, we can start just by dividing by 2. So to create a division node, you just do the divide symbol \2. Just like before, it'll create this divide node, but it'll default this to a value of 2. So it'll decrease our twist a little bit. We can also make this into a slider. So I'll start at 3.0. And we can kind of mess with the range of that twisting. Here, we can also go in and start to change this curve, which will change how our twisting is working. So we can go anything from pretty straight to a pretty extreme curve at the top. Okay, so that's our final twisting tower, and this tutorial introduced the basic ideas of associated design and architecture, using Grasshopper to create dynamic models that can be driven by a series of parameters and give you control over the geometry. We also introduced several different ways of working with geometry, anything from creating ranges and series of numbers to kind of visual control of data based on the graph mapper, to actually instancing geometry from Rhino to drive data in Grasshopper.